I'm Emily Kumler, and this is Empowered Health. About 14 years ago, my boyfriend at the time, who's now my husband, came to me and said, if you want to cover a really big story that will have a massive impact on people, you've got to read the stuff this guy, Gary Taubes, is writing in the New York Times Magazine. And so I did. Pretty quickly, I realized what Bob had realized, which was that this guy was really onto something. He was uncovering stuff and looking back at the history of nutrition, sort of science, research, dogma, and how that has been passed down to the American public in a way that is making us fat and sick. So we decided we would get some camera equipment and we would go around and try and find the people who were involved in those original decisions. And we were able to interview some of the people who were involved in the dietary guidelines, which started as the dietary goals and then now is more known as the food pyramid, which is something that, really impacts all of us in terms of medical recommendations, in terms of school lunches. We have an episode coming up with Nina Teicholz, and she'll talk a lot about the influence of those dietary guidelines on the health of America. But what Gary did was, in the course of working on that documentary, which we didn't ever do anything with, we have all the footage, so maybe we'll use that somehow through Empowered Health. But he made me realize not only is there an incredible connection between investigative reporting and science, in that we're sort of both looking for this pursuit of truth or knowledge. And yet we are the most sort of fallible people or beings in that we can trick ourselves into thinking we've found something when we haven't. And that collaboration and working with people who can tell you where you may have gone wrong and accepting that kind of criticism and then refining your story, your book, your experimentation is incredibly important. And being able to replicate the story, right? Or being able to replicate the experiment is really important. And what we've learned since that happened 14 years ago is that actually a lot of the nutrition research that was done was based on epidemiological studies, which regular listeners will be familiar with as sort of like population-based studies, which is a great way of formulating a hypothesis. It is not conclusive, right? So people will say it's associations are made, which does not mean that anything causal can be claimed. And then they basically were just prescribed to the American public through all of these guidelines. And people are getting sicker and fatter, and it doesn't seem like anything is changing. Back when we interviewed Gary, or when I interviewed him in his apartment in New York with the cats crawling all over him, which was pretty fantastic, I was sure he was about to break open one of the biggest stories of our time. And he had, I think, finalized his manuscript for Good Calories, Bad Calories, which was his first big book on this topic. He's now published several and has another one coming out. He got some attention, but it has not changed things. Like I would say the pendulum has moved a little, but most people still think low fat is healthy. They still think counting calories is what you need to do. Exercise more, eat less is still sort of the motto of America. And it's certainly something that we have now outsourced to the rest of the world. I'm thrilled to welcome Gary to this podcast. He and I could talk for days. So we talked for more than 2 hours. We decided to split this podcast into 2 episodes and just kind of let it run. He is such a wealth of knowledge. And I think what most people don't understand is that, yes, he has become sort of this activist for nutrition, but it's sort of akin to any other investigative journalist who uncovers a public health crisis and finds and identifies the flaws in the theory and then watches as nothing changes.
My name is Gary Taubes. I'm an investigative science journalist turned author turned nutrition zealot. Spent the last 40 years of my life studying controversial science, good science, and bad science, and the last 20 years focusing on nutrition and trying to write what appeared very clearly to me anyway to be some serious screw-ups in the science that's been done and the conclusions that the authorities came to.
So I feel like a good place to start is this idea of sort of the connection between journalism and science, and the idea of sort of like critically looking at something and trying to poke holes in, your piece or your experiment, or you're, designing a kind of like a hypothesis and then going in and doing actual reporting or investigating and figuring out what it is. You have been converted into more of like activists. And I would imagine that makes it hard to go back to the sort of reporting. I mean, it's not even talking about bias so much, like the analogy that I made, like you looked at the Spotlight team that broke the stories on the Catholic Church sex scandal, and you basically told those journalists, like, okay, great job, but now you can no longer report on sex abuse, on children, on religion. Like, that would be insane. So what has happened? You have approached this with great rigor, and yet you have been pigeonholed into a beat, basically. I mean, like, this isn't the only thing you've ever covered, but it seems like this is now what you are known for.
Yes, and there are a lot of issues that you raise. Science and investigative journalism are very similar in that you are trying to explain phenomena that you're seeing and come up with reliable knowledge about the universe that nobody has. In that sense, so when I think about the ultimate kind of definition of the scientific process, there was a quote by the philosopher of science, Robert Merton, who said that everybody wants to know what's really so. Scientists want to know that what they think is so is really so. So another way that a line that I've quoted in virtually all of my books from the Nobel laureate Richard Feynman is the first principle of science is you must not fool yourself and you're the easiest person to fool. So what scientists are trying to do, you're trying to establish something reliable about the universe or about the human body or about diet and health, and the key word is reliable. So you don't want to be fooling yourself, you don't want to be fooling other people, you want to know that what you know is really so, and when you're an investigative journalist, that's the same goal. So when I set out to understand this relationship between diet and health, and when Nina did, you talk to the people involved, but you don't necessarily take their word for it because they may be fooling themselves. Or they may be fooling you, but most likely they're fooling both of you. So you have to go and do your research. If somebody says this is true, do I believe it or do I go to the papers to see if it's true? And if the paper cites earlier papers, do I go to the earlier papers to see if they were cited correctly? So you end up basically having to re-report the entire history of the field, and both Nina and I did this, so that we could then understand that what we think is true really is or not. You know, if we're basing our knowledge on assumptions, what knowledge are those assumptions based on? And is that knowledge correct or not? And so you have to understand the whole history of the field. It's a line I have in my new book where I say, isn't it almost literally to know what you're talking about, doesn't that require that you understand the basis of your beliefs? And the basis means when they arose, why they arose, what evidence supported them, what evidence didn't, and how that evidence evolved. Like a lawyer would have to understand, the precedents to a legal argument they're making. That's effectively what Nina and I did. The problem is we came to the conclusion, both of us, that the conventional wisdom is not just misguided, but dangerously so. That the research that was done was unacceptably poor, that researchers effectively didn't believe they could fool themselves. So if they got a result, they just said, hey, look, I got a result. This must be true. It confirms what I believed all along. I'm such a smart guy. Let's assume it's true and move on. And you still see the same kind of sort of very dangerous thinking today in the scientific enterprise. So by concluding that the conventional wisdom was wrong and the authorities were wrong, we then had the decision, do we just write our books and move on? Or is there an injustice here being perpetrated, like the Spotlight team? Do they expose the Catholic Church and move on? If the Catholic Church continued to do the wrong thing on the sexual abuse issues and insisted that the Spotlight crew had erred, that they had gotten it wrong, that they were, in fact, doing their job poorly, then you have a different situation, because the societal forces in the church moved towards accepting that what they wrote was correct, and because it was in the context of a major American newspaper. So, for instance, if either Nina and I or I were staff members of the New York Times and did our research in the context of the New York Times, it would have had more effect at the time, and we would be treated differently.
But I feel like you guys have both published in the best outlets out there.
Oh, we have, but as freelancers. That's a different, we don't have, I remember a friend of mine used to say that working for the New York Times is like having a magic suit, a magic jacket. You put it on and people suddenly respect you.
How many New York Times Magazine cover stories have you had? 3?
3. but I'm still not a New York Times reporter.
No.
By the way, I've had opportunities to be a New York Times reporter and turned them down. I'm just saying from what happens to you so for instance, let's say after writing What If It's All Been a Big Fat Lie, the cover story in the New York Times, I kind of set this off, this infamous cover story. I then got hired by the Times. Instead of taking a book advance and spending 5 years writing a book, I then got hired by the Times. The editor said, boy, this is fascinating. This guy is good at what he does. Let's bring him on board and assign him to continue investigating this story. So I could have done what I did for my first book is a series of articles and investigations in the New York Times. And it would have been, in many ways, a lot easier because they give their investigative journalists a lot of time and leeway, or at least it appears to be the case. That you could spend a year or 2 years or 3 years, if necessary, as long as it takes to make sure you get the story right. And then instead of coming out in the book, which published by Knopf, which is one of the 2 or 3 most well-respected publishers out there. It came out as a series of investigations in the New York Times. Even better if I have multiple investigators working with me and we could be the New York Times spotlight team instead of just Gary Taubes. We'd have changed the world. I mean, the world would have changed far more quickly than it is currently changing. But that's not what happened. In order for me to understand this, it turned out I had to take a historical approach to the literature. So I found myself going further and further back in time to try and understand this relationship between diet and weight and chronic disease. And what I had no idea when I started this is that prior to World War II, there was a alternative hypothesis of why we get fat. So since the post-World War II years, the idea has just been, look, we eat too much. I mean, the medical community, the researchers like to talk about this in make it seem as complex as they can. But the reality is the basic hypothesis is we take in more calories than we expend, and that's why we get fat. And then in the 1960s, on top of this, they said, hey, fat calories are really dense. You know, there's 9 calories to a gram of fat compared to only 4 to a gram of carbohydrates and protein. So you're probably going to be fooled into eating more fat than carbs or protein. And that way, that makes fat fattening as well. But it's all about eating too much. Gluttony and sloth would be the biblical terms. It turns out that prior to World War II, when all the major scientific advances in the world basically came out of Europe, science was a European invention. Medical science in the U.S. was virtually non-existent until the early 20th century, and even then it was pretty piss poor. If I were to name the leading scientists in any endeavor pre-World War II, they would almost 95% of them would be Europeans, Germans, Austrians, Danes, Frenchmen, Italians, Englishmen, mostly Germans and Austrians, and a high percentage of Jews. And for whatever reason, they honed this scientific method, this idea about not being able to fool yourself to a fine edge. And by the 1920s, 1930s, the German-Austrian clinical investigators, these are physicians who ran clinics, who also did research, had concluded that obesity had to be a hormonal regulatory defect. That there are all these questions about fat accumulation that you could not answer just by saying people eat too much. So if I wanted, for instance, why do men get fat above the waist and women tend to get fat below the waist? You know, men get beer bellies, women, it's the hips and butt. What? Clearly hormones are involved. Or they would ask questions like, you know, boys go through puberty, they lose fat and gain muscle. Girls go through puberty, they gain fat in very specific places. So by the time they come out of puberty, the girls have 50% more fat than the boys. That's a hormonal phenomena. Sex hormones are involved. So these German-Austrian clinicians had concluded that people don't get fat because they eat too much. They get fat because there's some hormonal dysregulation. They couldn't figure it out. And then World War II comes along, and this is what I realized doing my research, and this German and Austrian school evaporates. Post-war, nobody cares about obesity in Europe. They have serious other problems to deal with. And the obesity research is kind of recreated with its core in the U.S., all these young doctors and physicians and psychologists And psychiatrists are convinced obesity is an eating disorder. Fat people just have some neurotic problem that makes them eat too much. And you get this sort of misguided eating too much thinking ever since. Again, when I started my research, I had no idea about this. But it's sort of like you could imagine a world in which, when we talk about cancer, when people study cancer and tumor growth, they're studying all the mechanisms that drive a tumor cell to grow. They don't care how much the person eats or exercises. What they're worried about is what are the mechanisms, the tumor suppressor genes and the oncogenes that are dysregulated such that this tumor is being driven by the body to grow and reproduce and metastasize. And the way the Germans and Austrians thought about obesity and fat accumulation was fat cells are driven to take up excess fat in some people, but not others. And in some places on the human body, but not other places. And if they understood those hormones and enzymes and receptors and all those molecules that drove a fat cell to take up fat, they would understand obesity. And then post-war, we just threw all that out.
So do we throw it out because we were like anti-German? I mean, is that the reason?
Part of it was that. Part of it was to really understand the science, you had to be able to read the German language. So the lingua franca of science pre-World War II was German. If you were a serious scientist in effectively any field, you had to be able to read the German language literature. Post-World War II, we didn't like the Germans that much, and we didn't like the Austrians that much, and nobody wanted anything to do. And in fact, some of these leading researchers, like Jean Mayer at Harvard, had fought in the war, and one of his colleagues said he hated the Germans, killed a few of them.
In other fields, don't a lot of German scientists come to the United States?
Yeah, in physics, we embraced these people. We had bombs to build. I mean, there was programs by British scientists to bring German and Austrian, particularly Jews, to the U.S., to give them, and to England, and to get them settled, get them academic positions, rebuild their careers, but not so much in medicine and public health.
I mean, I feel like America is pretty good at appropriating ideas of other places that are good ideas and then just calling them their own. So it's interesting that we didn't do that.
Well, in part, and this would make an interesting book on its own, but the Ivy League universities had protocols in place to keep from being overrun by Jewish students and academics from Europe. In fact, one of the stories, I live on the border of Berkeley and Oakland and California, and one of the stories about why the University of California system is so excellent and why Berkeley in particular is so excellent is these Jewish researchers basically just kept moving west. Nobody really wanted them.
Wow.
In many fields, and then they got to California, and the California universities embraced them and had world-class science as a result. If you look at the Manhattan Project physics, it was full of Europeans and European Jews who were basically creating the atomic bomb to stop Hitler or to beat Hitler to an atomic bomb. But in medicine and public health, they just didn't really want these people. Some of them got established, like Hans Krebs, the famous Krebs site, the bane of high school biology. But many of them, the leading authority on obesity was a fellow, he fled Austria. He was at the University of Vienna. He's a very famous scientist. Austrian medical researchers today still know his name, a fellow named Julius Bauer. And he flees Austria in 1938 when the Germans invade, and he ends up working in Baton Rouge for a year at LSU in Louisiana, and then he drifts out to Los Angeles, and he gets a job working for the Hospital of Medical Evangelists, which is a Seventh-day Adventist hospital. Would write his papers were just signed Julius Bauer, Hollywood, California, which I guess is where he lived. And this was a world in which one UC San Francisco researcher, when I asked him about why his work on insulin and wasn't well accepted, he said, well, back in the 60s, 70s, and 80s, as we used to say out here, the Mississippi River ran wide and deep. So basically, this world was dominated by this East Coast corridor of researchers, and obesity was a half a dozen white men who were all buddies, and literally they were friends, they knew each other, they hired each other, they published each other's papers, and they went from Tufts on the north end down to Penn in Philadelphia, and what they said was gospel in the obesity field. And if somebody wasn't part of that club, they weren't taken seriously. It's hard to imagine. It was a very small field.
But what I find so fascinating is that it's like, it seems to me like there is some sort of turn of events that happens, and I associate it with Ancel Keys, where it's like the idea of scientific rigor no longer seems so important. And that I just don't really understand. I mean, it goes from being pretty critical thinking in other disciplines, right? And then this sort of field of nutrition comes about. There's a realization that we need to have, like the Harvard School of Nutrition is born. And like with that, why is all sort of scientific rigor thrown out?
I'm going to wing this right
Go for
now. So you think about through the World War II, most of nutrition was deficiency diseases and calorimetry, measuring energy in and energy out. But basically, it was studying deficiency disease. So animal or human lacks a particular vitamin and mineral, they get a disease like pellagra or beriberi or scurvy, and then you feed them back the missing vitamin, and it goes away. So you could actually do experiments. The scientific method is hypothesis and test. You have a hypothesis that you get scurvy with a relative absence of vitamin C in the diet. If I add back vitamin C or fruits with vitamin C in it, the scurvy goes away. I could test the hypothesis by experiment. Beginning in the 1950s with Ancel Keys and this dietary fat hypothesis of heart disease, you get a different type of hypothesis. Now not aimed at a deficiency disease, it's aimed at a chronic disease that develops over years and decades. So now we're saying we get heart disease because the fat in our diet or the saturated fat in our diet raises total cholesterol or LDL, the bad cholesterol. And that cholesterol then builds up in the bloodstream, and over the course of 10 or 20 years, it manifests itself as atherosclerosis and heart disease. But now we can no longer test it. We can't just take away saturated fat and expect over the course of a year or two or 6 months, however long you could do a well-controlled experiment, that you will see a change in heart disease, because you're looking at a process that takes 20 years and may not reverse quickly just because you remove the cause. Once you've got the atherosclerosis, there's no reason to think that removing saturated fat is going to make it go away. You suddenly have hypotheses that can't be tested.
But you're also making a huge assumption there, right? Because the assumption is that cholesterol is the driver when you haven't identified what the root cause is.
Yeah, but that's the assumption. Ideally, you would be able to test in a functioning science. You would come up with a series of experiments, and the cheaper those experiments are, and the more quickly they can be done, the more functional the science. So ideally, you might do 50. I've talked to physicists about this, where they talk about back in the 50s getting an idea on a Friday night, arguing about it over the weekend, and then going into the lab on Monday morning and putting together the apparatus to test it. That's wonderful science when you can do that, because you can do hypothesis and test, and then you can replicate the test as many times as possible to know that you did the test correctly and keep probing this question of whether you're fooling yourself. But if you now have a hypothesis that can't be tested, you've got a problem. And you've got a hypothesis that you convince yourself is vitally important, right? People are dying out there. I used to think of this as a Jurassic Park factor. And remember the first Jurassic Park, about a half a dozen times, somebody says, people are dying out there. We have to act. But now we have a hypothesis of how to keep them alive that we can't test. Or if we do test, it takes $1 billion in 10 years, and we won't be sure that we get the test right. So it's going to be at least $2 billion in 20 years, and maybe more like $3 billion in 30 years. So one way to deal with this is to have been very tentative and said, look, we got this idea that dietary fat causes heart disease, and we're not sure about it, and we can't test it. This is good scientists. Part of good science is being tentative with your conclusions, because you're probably fooling yourself. So you want to give yourself room to be able to back out when somebody else demonstrates that you are fooling yourself. So you give these very tentative pronouncements, and you say, we're going to try and test it, but it's going to take like 30 years. But in the meantime, if you people never want to eat butter and bacon again, I think you'd be going to live longer. And the problem with that is if you give that kind of advice, nobody's going to follow it. people are going to say, you're telling us that we should never eat butter or bacon again and we may live a little longer? How much longer can we expect to live? And then they'd run the numbers and say, well, a couple months, according to our data. And you'd say you're out of your mind. And then you don't get any public health effect and people continue to die out there. So what happened over the course of 20 years is the research community kind of agreed by osmosis to lower their standards and to pretend something was true and to ignore all the times they didn't live up to rigorous science. So they started saying, well, let's do observations, and if we observe what we expect to see, maybe we could then conclude that somehow there was a causal fact, that we were right all along, or we'll do these lousy experiments, and if we can find in those experiments what we expect to find, we'll forget that they were lousy experiments.
And I feel like there should be some sort of like an awareness at that stage that no matter what you find, you're not going to be able to conclusively say that that was the right thing that you found, right?
Right, but remember, in order to get people to change their behavior, to have the public health effect that will stop people from dying out there, there's two vitally important factors. One is your advice has to be right. And second, people have to follow that advice. And for the people to follow it, you have to make sure that they know the advice is right, that you make very definitive statements, and maybe that you make it seem even more important to them than it really is. So they could never know that the advice was right, but they knew that they had to make the advice firm and definitive. I say they knew it because it's in their writing. You could see it in the discussions of.
But this is like politics versus science, right? I mean, like this is not the same like thing. Yeah.
They cease to function as scientists. They accept something on faith. Dietary fat causes heart disease. It raises LDL cholesterol, and we should all eat low-fat diets. And then they become, and I say this in the epilogue to Good Calories, Bad Calories, that I never use the word scientist to describe these researchers because I didn't believe they functioned as scientists. Once they started into this chronic disease business, rather than realizing that they couldn't know the truth, they pretended that they could. They convinced themselves that they could, or that they already did, which is worse. And then they proceeded to try and get us, and what they succeeded at was getting us to change how we eat.
And so if we're going to put this in that kind of context, I think it's probably important to add in the sort of the influence of money and funding research and how that has like sort of furthered these individual or egotistical agendas in a way that maybe wasn't so much of an issue before?
Yeah, that's an interesting question. And Nina and we've had many arguments over this over the years. To me, it's the scientists failed. The researchers failed to do their job, and their job is to establish reliable knowledge. And when they should have realized that they can't do it, they should have admitted that and made sure that we then didn't proceed to fool ourselves and everybody else. So to me, it was a failure of the science. On top of that is layered some funding influences and how this research is funded. So if you think about high energy physics, the field I grew up writing about, the physicists decide that there's, a few questions that are vitally important for them to answer. Is there a theory of everything, a grand unified theory? Are there particles out there that are not predicted by the well-accepted, well-tested standard model? And what do we have to do to answer those questions? And the answer is we need an accelerator so powerful that we can't even afford two of them. We're going to build it outside of Geneva, Switzerland. Everybody's going to pool their money. It's going to cost $10 billion. Then we're going to build 4 different experimental detectors on the accelerator so they can make sure if you see it in one experiment, you can replicate it in others. It's going to cost a couple $2 billion a year to run, but this is what we have to do to answer the questions. And that's what they did. And we trust their answers. In nutrition and medicine, you've got basically the NIH saying we are going to spread the money as widely as possible. We don't know what we want to know. So we're going to look at proposals from thousands of different researchers, and we're going to sift out the proposals we think are the best, and we're going to give them all, $500,000 a year to fill their research, and that's the max. And there's no real mechanism to answer the big questions. You hope that out of all these little questions, so you, on one level, the research establishment is set up in such a way that it generates noise, thousands of little results, none of which can be trusted, and never addresses the big questions, and never generates a signal, a meaningful answer that can be trusted. And when they actually did spend a lot of money to do big studies, $500 million to do what was called the Women's Health
Initiative.
What was the initiative? Thank you. WHI. They didn't get the answer they expected. They decided they did the study wrong. And again, that's a catch. They might have done the study wrong. That's why you have to replicate the experiment. They should have spent another $500 million. Let's go back to the 1960s. One of the famous studies that was cited as evidence that eating less saturated fat and more polyunsaturated fat was reduce heart disease, at least in men, was done in a VA hospital in outside of Los Angeles. I think it's the one in Westwood, right next to UCLA. And they fed these various veterans at the hospital. They'd come in and they'd get foods that were either, use butter and dairy or polyunsaturated margarine. And lo and behold, after a year, they had a little less heart disease in the group getting the polyunsaturated fats. They also had more cancer.
This is like the Minnesota study, right?
Yeah, kind of. So in an ideal world, they'd have done that study, gotten a result, and then said people would have argued about the interpretation of the study. Well, how do you know that the reduction in heart disease that you saw wasn't caused because the foods made with the polyunsaturated fat margarine taste so bad that these people just ate less, particularly the food-like desserts that they made in the 60s out of this margarine might not have been as good as the food desserts made from butter. So not only might they have eaten less less saturated fat, they might have eaten less sugar. This is the kind of discussion that scientists have, because you want to make sure that you're not fooling yourself. So what they'd have done in an ideal world, instead of that experiment taking a year to prepare and then a year to carry out and 6 months. In an ideal world, that would have taken a week. And then they'd have argued about this, and they said, well, let's do it differently. Let's come up with this, and we'll make better desserts, and we'll test the desserts first, and we'll make sure that people can't even tell the difference between the different types of desserts. And when we have desserts, you can't tell the difference. We'll do the experiment again. And you'd have just kept doing it and iterating towards something reliable. But you'd always have had people arguing about the interpretation. Well, what about this? What about that? And every time somebody said, what about this, they'd have to come up with a new version of the experiment to account for that. So they knew whether or not that really mattered or whether they could ignore it. You couldn't do that in nutrition. So instead you get this, oh, hey, look at the result, less heart disease. Let's believe that's true. And for the rest of eternity, we'll tell people to eat low-fat diets and replace it with corn oil because it's got polyunsaturated fat in it. It's not science.
But there is something about that's troubling, right? It's troubling for a number of reasons, but it's really troubling by just the idea that somebody is so wedded to their hypothesis that it's almost like, why bother doing the experiment, right? You know that I interviewed Mark Hegstead a million years ago, and I feel like one of the things that he said to me that was so upsetting, although magical that he said it on camera, was he was talking about the women's or the nurses' health study. And he was sort of saying, with something like that, when you get the result that you thought you were going to get, you can trust it. But if you get a result that doesn't look like what you thought you were going to get, then you have to question your data.
And that's exactly, it's amazing that he was honest enough to say that, but no, you can't trust it. And you go back all the way to Francis Bacon in 1620, the British lawyer who sort of inaugurated the scientific method. His very point then was you can particularly not trust the stuff that you expected to get. And you can almost trust the stuff that you didn't. So it's exact opposite of the way good scientists think, and yet this is the kind of thinking that's driven this field and that we're still fighting against. Today, you see it all the time, particularly in epidemiology, and particularly epidemiology out of the Harvard School of Public Health. If you get what you expect to get, and there's a version of this that's even worse, which is if you don't get what you expect to get, you don't publish it because you assumed you made a mistake.
Right. Or in that Minnesota study where they published it 17 years later and then tell you when you ask that question, right? I mean,
yeah. So the Minnesota study, they use various rehabilitation homes in Minnesota. They feed them the inpatients in these homes various either polyunsaturated fat or saturated fat rich diet, and they look at who gets more heart disease and who lives longer, and lo and behold, they get, quote unquote, the wrong result, which is that the people getting what they thought of as a healthy diet had more heart disease and a higher mortality rate than the people getting the unhealthy saturated fat rich American diet that everybody else was eating. And so, yeah, they don't publish it. And so 17 years later, they did. Ivan France Jr., who was the principal investigator, published the results of the study the year after he retired from the University of Minnesota. But by that time, this low-fat dogma had been inaugurated, this institutionalized, various government reports had come out telling us all to eat low-fat. So he felt an obligation to publish this data. And when I asked him, I interviewed him 15 years after that, and I asked him why they didn't publish originally, and he said because one of the co-authors, who was Ansel Keys, he didn't name Ansel Keys, but he said we didn't like the way it turned out, so they just didn't publish it. They assumed that they got the wrong answer. All of scientific method, all of this critical thinking and skepticism and rigor and everything Bacon was saying in 1620 was how to fight that tendency, how to minimize this very human tendency to believe what we want to believe and see what we want to see. The medical nutrition community, and again, part of my feeling is I just think they've got no real mentoring in good science. So one of the lessons you learn when you talk to good scientists and you read the memoirs of good scientists, which I've been doing, is you're not born a good scientist. I mean, there are people who are born brilliant, but there are very few people who are born understanding how easy it is to fool yourself.
Well, and I think this idea of like the cognitive dissonance is sort of what you're alluding to. And I think that is fascinating in the sense of like, this feels very fraudulent, right? Like it feels like if somebody has a doubly blind clinical trial and it shows something different than what they thought, that is worth sharing with people, especially if it's going against what everybody's being told to eat on a regular basis, right? And so to bury that for 17 years, but you know, Malcolm Gladwell did a really interesting podcast on that too. I don't know if you heard that. Yeah. He talked to the guy's son who like found the records or whatever. And I mean, that was like an emotional episode, which was sort of interesting.
That was Ivan France III.
But, you know, he talked about how like he thought his dad really believed that. Like that's what they were all fed. And so that for me is another layer of this, because if it was fraudulent, right, then he would be saying to his family, like, don't eat that shit, right? Like stay away from it.
It's not fraud. It's not fraud. It's back in the term I prefer is pathological science. Pathological science is a term coined by a Nobel laureate in chemistry named Irving Langmuir, and it's a definition of what he called the science of things that aren't so. And so the thing with pathological science, it's not fraud. Nobody's trying to deceive you because they know the truth. They're trying to deceive you because they've already fooled themselves. They have a lack of understanding about how hard it is to get the right answer and how easy it is to get the wrong one. And so they're not following the strict scientific methods that are required to minimize the possibility that you'll fool yourself. Not to get rid of it, because you can never get rid of it, but just to minimize it. So people like Ivan France Jr., the fact is these experiments are really hard to do, and they're really easy to misinterpret. That's why you have to replicate. Part of the scientific method is this independent replication. So it is quite possible that you screwed up the experiment. So what you should do is just do it again.
Well, and so then you add in a character like Ansel Keys. And like, will you talk a little bit about how influential he was in sort of creating this dogma?
Keys was, it's funny, the phrase used to define Keys when I was doing my reporting was he doesn't suffer fools gladly. That's usually a kind way of saying he was, I don't know, what kind of words can I use on your podcast?
Whatever you want.
He was an asshole. And he was convinced he was smarter than everyone else. So this is the problem. Really smart people. Remember, anyone can be born brilliant. The hard problem is being born a good scientist. So the fatal flaw of really smart people is they tend to think they're so often they're the smartest person in the room. They tend to think they always are. The rest of us are used to being confronted with the inadequacies of our intellects. They're not. So Keyes was the kind of guy who convinced himself that he knew the right answer, and then methodically, unconsciously rejected any study that disagreed with him and any researcher that disagreed with him, although occasionally along the way he would realize that he had been pushing the wrong answer, and then he would embrace the right answer and kind of act like he had always been right. By the 1960s, so he started pushing this hypothesis around 1952-53. By the 1960s, he had started this hugely influential 7-country study that was ongoing in Europe, and he had convinced the American researchers to do these experiments like this Los Angeles VA hospital study, all to test this hypothesis. And what happened was the existence of the hypothesis was perceived by this community as evidence that it was right. Again, exactly the wrong way to think if you're a good scientist. But just the existence of these studies, and you could see it when people would write about it, even the journalists would talk about the hypothesis hasn't been proven yet. And whenever I'd see that word yet, I'd think, but it may never be proven. It may be wrong. Mm-hmm. So it hasn't been proven wrong yet either. Right. But the most likely, the odds are always good that your hypothesis is wrong. There's an infinite number of wrong hypotheses for every right one. So anyway, because of Keyes and his motivation, then the 7-country study, which Keyes interpreted to support his beliefs. There were multiple ways it could be interpreted. It wasn't an experiment in any sense, so one way or the other it can only generate a further hypothesis. But because of Keyes and his refusal to accept criticism of his thinking as valid and the strength of his personality, he convinced us that dietary fat was a problem. The research was ambiguous. It was Keyes' force of character more than anything that drove this hypothesis, and then this sort of societal acceptance set in. But the other thing that I found more interesting, which really wasn't Keyes at all, was the obesity story. By the 1960s, we should have had a pretty firm awareness that the carbohydrate content of the diet effectively regulates how fat you get. Okay, so the more carbs, the easier they are to digest, the more sugar, the higher your insulin levels, the more calories you store as fat. But the problem was we were pushing dietary fat as the cause of heart disease. That was Keyes' work. And if fat caused heart disease, you couldn't tell people to eat less fat and less carbohydrates because you were replacing the fat with carbohydrates. So an indirect consequence of the dietary fat hypothesis was a refusal to accept the data implicating carbohydrates and fat accumulation and obesity. And as a result, the conventional wisdom on why we get fat went from, by the early 1960s, it was still, carbohydrates make you fat. And one of my favorite lines from a first sentence of a British Journal of Nutrition article in 1963, written by one of the leading British dietitians, was, if every woman knows that carbohydrates are fattening, which is what every woman used to know. And then because of Keyes and the dietary fat heart disease hypothesis, by the 1980s, carbs had been transformed into heart-healthy diet foods. And people like Jane Brody, the personal health reporter for the New York Times, was writing her Good Food book, bestseller in 1985, is living the high-carb life, and she's pushing pasta as a diet food. And I wanted to say, Jane, go to Italy, look at the older women, tell me if you think eating pasta was good for their weight. And in fact, even Ansel Keys had pointed out that all the older women in Naples, where he lived, were fat. I'm going to get in trouble for this, so I don't mean this to be sexist.
But I also think that sort of gets into this idea of metabolic derangement, right? Or that over time, this idea of oh no, my kids can eat tons of sugar. They don't get fat. And it's like, well, over time, you're damaging your system.
Yeah.
Under regulatory system is the definition or the defining force in your health, not what you're eating today or how many calories you're taking in, but the content of them. Can you talk a little bit about that and like the role that we have placed sugar or the sort of altar of love and affection and celebration? You have that great chapter in The Case Against Sugar about like sugar kind of in the context of any other drug where it's like having this effect and we're using it for these moments in life.
It's funny because that was a thought experiment that I once had where I was thinking there's just no way I could ever use this in my book because it would just play the hand immediately. Like I want this book to be a dispassionate discussion of the evidence against sugar, and I can't say this. And then I wrote this out and had the person in the field who I think is the best scientist and who's always willing to tell me when he thinks I'm full of crap. I had him read and he said, oh man, you got to use this in the book.
Wait, can you say who that was?
Mark Friedman, who's one of the few really good scientists in this field, in part because he wasn't in nutrition or obesity research, so wasn't infected by that culture. But anyway, the idea is just imagine you have a drug that mothers can give to their infants. It's a painkiller to begin with, but also makes them high. Treats for infants is a rush. It's like a drug to adults, and so you can, whenever your kids are unhappy, you can give them this drug, and it'll cheer them up and make them smile. And if they hurt themselves, you can give them this drug, and it'll kill the pain. And how long would it take before you started using this drug to sort of reward achievements or to demonstrate love? So it's like, I love my child. I want to prove to my child that I love them. I want to give them this drug. So we're going to go out, or I'm taking my child shopping with me and it's a boring experience. But if I drug him or her, they will be perfectly happy and I can do my rounds at the mall. Or, and then it's going to be whenever there's a celebration and we get the family together, maybe this is a drug we should give them to keep the kids happy, to make them glad to be stuck with their aunts and uncles. When I drop my little Janie off at grandma's, what can grandma give Janie to make Janie want to be there? Well, they give them this drug, and how, this drug would pretty quickly become sort of a symbol for love, the currency of love, the currency of celebration. It's what, and how long would it be before every major national holiday or even created holidays have use of this drug as candy? And you could just imagine how all you would need is something that made your child happy. And we don't think of it as a drug, it's a food. That was the thing with sugar, is that it was both a food and a drug. It was unique in this sense, or seems to be a drug. It certainly has psychoactive properties. Like, we know it's a painkiller at the very least.
But it's interesting. I was actually talking to a friend of mine at a kid's birthday party recently about how everybody serves cake at the very end of the party. And it's because the kids are all super happy and then they're all crying. And it's like, time to go home.
Yeah.
And it's like, nobody takes that out of context to say, like, is there something in the cake that's making the kids cry? Instead, we all focus on the positive of like, oh, it's cake time. Everybody come get your cake on.
Yeah. And I did the same thing. I remember the first time we let my youngest have Halloween candy. He was 3, and we let him have like 4 pieces of candy after Halloween. And that night, he ran around the house naked for like 20 minutes, screaming with joy. And then I said, it's time to go to bed. And he threw himself down on the stairs and started crying hysterically. And I turned to my wife and said, if we had given him cocaine, I don't believe his behavior would have been any more extreme or bizarre. I mean, it was absolutely fascinating. And yet we just write this off because we've been so inculcated with this stuff. This just is the way it is.
The cultural aspect of it is like such a big one, too, because like when we had our son, we kept him off of sugar for the first year, like pretty absolutely. He had berries, but I think that was pretty much it. And at his first birthday, we had one grandparent who will go nameless, who like sort of insisted that he should have cake. And we were like, no, the cake is for everybody else. He's never had sugar. Like, he doesn't need it. He doesn't care. He's one. He's not noticing that he's missing anything. And she was apoplectic that we were depriving the birthday boy of a piece of cake. And I thought, this is so this is so much about you, right? Like, this has nothing to do with the child's needs.
It is. And imagine if you were, if you grew up in a world where everybody was a drug addict and you knew what joy it brought them, short-term joy, and there might be long-term problems, but the short-term, this drug tasted like just made you happy. How could you possibly keep your children from that, or your grandchildren, or your great niece, or whatever it is? And it's just, and maybe it is harmless. I don't think so, but maybe it is. If it is, then Jesus, this isn't just about living as long as we can. It's supposed to be about living well, too.
So you were going to say something about Coke and Pepsi, too. I feel like the introduction of sodas.
Oh, they get to advertise themselves. I mean, you look at the pause that refreshes. It's not just about quenching thirst. It's about making you feel good. It's a rush. It's a exhilarating experience drinking an ice cold Coke.
It's patriotic, too, right? I mean, I feel like there was a lot of work done around.
Yeah, I mean, it became, well, at one point, it's probably still true. Coca-Cola was the second most recognized word in the world after okay. And I say that without any understanding whatsoever of how they calculate that. But let's assume that somebody out there figured that out knew what they were doing. And the Coke people, you read the histories of Coca-Cola, which I did doing my research. I mean, these people just believed in their product. They didn't think, I don't know what the cigarette people believed. I've tried to read those books, and they're so relentlessly negative that it's almost hard to believe that they were as bad as they're portrayed. But clearly, the Coke people their product was joy. That's what they were selling. And it's a great mixture, sugar, caffeine.
But it started as a medicinal thing, too. I mean, that's interesting.
Yes, and also with cocaine in it. And then the Coke, hence the Coca-Cola. And the Coke was taken out in the early 20th century when the FDA took offense. But it was a medicinal thing. It was the guy who founded it had Civil War wounds that were chronic pain. And this was a way of reducing the chronic pain. Tying it back up to the dietary fat story, and Ancel Keys, so back in the 60s, there was a competing hypothesis. Keys was saying dietary fat causes heart disease because it raises LDL cholesterol, and you should measure this one number, cholesterol, and if that's high, we know people are eating too much fat. Everything we believe today in the medical community sort of springs from that nugget of thought. That's the root of that tree. There was a competing hypothesis, which is that heart disease is a metabolic derangement. Everything's wrong in the human body. It's not just LDL cholesterol is elevated. Measure virtually anything, and it's abnormal numbers in people with heart disease, and whatever's happening is very closely related to obesity and very closely related to type 2 diabetes, very closely related to hypertension, and all these disorders sort of coexist in people and populations. So if you're overweight, if you're fat, you're more likely to be type 2 diabetic, you're more likely to have atherosclerosis, you're more likely to have hypertension, and so it's this metabolic disruption that happens to be caused primarily by sugar, because we can add sugar to any diet. In clinical trials, experiments were done in the 60s demonstrating that virtually all of these facets of this metabolic disruption could be caused either in animals or college student subjects by feeding them sugar. And the guy who was pushing the sugar hypothesis, a brilliant British nutritionist named John Yudkin, and Keyes didn't like each other because Yudkin had criticized Keyes, and Keyes didn't tolerate fools gladly or anyone who criticized. So Keyes went after Yudkin and basically wrote a long screed explaining why he was a quack and why this theory shouldn't be taken seriously. And then the sugar industry, which was being attacked because of Yudkin's sugar theory, put together a paper, a 120-page journal supplement with a about 7 or 8 different articles in it explaining why sugar didn't cause heart disease and didn't cause obesity. And everyone in it was part of the sort of anti-fat movement. All the authors believe fat was the problem, not sugar. And several of the authors worked with Keyes at the University of Minnesota. And so by the mid to late 70s, a fat hypothesis was being accepted, and the sugar hypothesis was being considered quackery. So the worst you could say about sugar is it's empty calories, and you shouldn't eat too much of it. And anyone who said anything else was considered a quack. And again, this was largely Keyes' work, because he didn't, the problem was the fat in our diet by this thinking, not the sugar. So from the 80s to the early 2000s, virtually no studies were done on sugar, and certainly not these like $500 million studies like the Women's Health Initiative. I like to joke that if you tried to get a Women's Health Initiative done with sugar, you couldn't get it funded because the answer would be obvious. The NIH would say, let me get this straight. You want us to spend $500 million taking 50,000 women and getting 25,000 of them to give up sugar because you think they'll be healthier if they do? Well, of course they'll be healthier. We're not going to spend that money.
I feel like that's probably a good place to pause. And we're going to pick it up again next week. We're going to talk to Gary a lot more about how we've gotten this wrong, but also we're going to ask him a little bit about the Nutrition Science Initiative project he co-founded to try and do the kinds of experimentation that he thought would be the right kind of experimentation to figure this out and what went wrong. Come back next week for the rest of this interview with Gary Taubes. And as always, thanks for listening. Please share on social, share with your friends. We're really trying to get as much of this good information out to people as we can. I'm Emily Kumler, and that was Empowered Health. Thanks for joining us. Don't forget to check out our website at empoweredhealthshow.com for all the show notes, links to everything that was mentioned in the episode, as well as a chance to sign up for our newsletter and get some extra fun tidbits. See you next week.